Today I'm going to keep it very simple. I'm just going to look at precedence tables and dummy variables, and I'll explain what that is with the help of some slides, and I will do some examples on the board as well. So potentially this is going to be a long video, so apologies for that, but I think it is for the best. So I'll be breaking in between the presentation and the examples on the board as I'm getting a bit more used to working with the iPad and recording with the iPad. So please be patient. I'm going to try my best to make this as clear as possible. I hope you find it helpful. I will upload the videos and the presentations in Classroom at the same time, so you've got all the visuals there, and hopefully it will all make sense. So basically, critical path analysis, it's all about identifying what are the different tasks that make up a project and identifying which ones are critical, so which ones you kind of move on before completing and which ones you can sort of move around. So if you think about, anything, you can apply critical path analysis to anything. Making dinner. If you're going to make dinner, you can break it down. If you're going to, even if you want to make something as simple as making an omelette, it's going to involve cracking the eggs, stirring the eggs, putting them on the pan, but before that you must have heated the pan with the oil, and then you do that. So then you mix it all together and you add your salt or whatever it is, or ham or whatever you want to have in the omelette, and then you put it on the plate and then you eat it. So you can break down what different tasks that need to happen before you actually get to eat the omelette, and think about which ones are crucial, which ones need to happen before the next, and so on. So and some tasks could actually run in parallel. So maybe you can put the oil to heat up in the pan while you crack and stir the egg in a cup. So and if you sort of extrapolate that to much bigger projects like buildings or major construction sites or IT implementation projects, critical path analysis becomes a very useful tool. So having said all of that and introduced the topic a little bit, we're going to go back to the presentation and have a look at that. I'll see you in a bit. Okay, hello again, good morning. So we're starting with critical path analysis, and we're just going to look at precedence tables today. So we're going to look at constructing a precedence table, how to model a project by an activity network, and understand the use of dummy variables, here called dummies, not a reference to any of you. And if you feel offended by it, maybe you've done something wrong. Okay, here we go. So you need to understand what an activity network is. Dependence, I'm pretty certain you know what that means. Dummies, I will explain in due time, and precedence, and again, assuming that you know what that means. So, in a precedence table, this is a bit of blurb here, but basically all we're doing is creating a table that shows which of the different activities in our project depend on the completion of a previous one. You cannot mix the egg in the cup before having cracked the egg. So the activity mixing egg depends on activity cracking egg. Activity frying egg depends on having completed activity mixing egg, if we stick to my omelette example. That's basically all that this means. So here we have an example. The production of a new textbook may be broken down into activities A to G. A and B do not depend on any other activities. C and D can only be started once A has been completed. Activity E cannot be started until activity B has been completed, and F cannot be started until activity C and E have been completed. And finally, activity G can only begin once all the other activities have been completed. Draw a precedence table to represent this information. Let's go back to the board to do this. So here we are again, back at the board. I have summarized the dependence of my activities here, but you've got that on the slides, okay? And a precedence table looks just like this thing here. I've got my list of activities A to G. and a column here next to it that says depends on. What does it depend on? Pretty simple, pretty straightforward. So A and B do not depend on anything. So I'll just draw a line there. They don't depend on anything. They can be started at the same time whenever. Now C and D depend on A. So very simple. C depends on A. D depends on A. You can see how this is going. E depends on B. Almost done. F depends on C and E. F depends on C and E. And here the last bit, G depends on all the others. We must have completed all other activities before doing G. However, in here we're not going to write A, B, C, D, E and F. We're not going to do that. If you look at it carefully, effectively G only depends on F. So I can just summarize that by saying that G depends on F, basically, because by saying that I've already covered all the others. F depends on, if I just summarize it here, F depends on C, which is in itself depends on A. F depends on E, which by itself depends on B. So I've got A, B, C. Well, the only one we haven't covered actually, there you go, is D. So I should actually have written there D and F. There you go, much better. That makes more sense. That's sorted. So I was just stressing the precedence of F because it covers quite a number of other activities. So G only depends on those two, and that's how you would construct the precedence table. Nice handy thing to do, like I did there, to realize that I had made a mistake originally and that D I should have included in there. Back to the presentation. From that precedence table example there, now let's look at activity networks. So basically a precedence table goes part of the way to representing the different activities that make up a project and which ones depend on which ones, but it may not be enough, it may not be as straightforward to understand as we need it to be in more complicated projects. So in order to improve the visual representation of the different moving parts in a project and the different dependencies, we're going to use something called an activity on arc diagram. There's other ways to do it, but this is the one that the book uses, and this is what we're going to stick with. So something to have very, very clear in your head. The activities, so that all the different tasks are represented by arcs. So I'm looking at the second paragraph here. And the completion of those activities are shown as nodes. So each arc is an activity, so we label it with an activity letter. And we usually use an arrow because we're moving from one to the other. The nodes, so the completion of each task, are numbered from 0 to until however many we need to complete the project, and we start at 0 because that's where we're starting from at time 0, time thing, and that's called the source node. Your beginning point in the activity network is the source node, and the final node is called the sink node. Because if you think about, like, I don't know, think about your bath, all the water eventually goes down the sink. So there you go. I don't know. Everything goes down there. So an example. Here I have a precedence table, which happens to be the one we had drawn before. That was the answer to our previous example. And now I want to draw an activity network to represent this precedence table. So let's go back to the board. Hello guys, still here, still around. Let's take this precedence table and turn it into an activity network, okay? So remember, each activity is going to be an arc with a letter, and the completion of each activity is going to go on a node. We start from 0, so my first node starts with a 0 there, and my first two activities don't depend on anything, so I've got activity A going in one direction, activity B going in another direction, and once I finish them, I've got node 1 and node 2. That's it. Now, C and D, activities C and D depend on A. So after I finish A, I can do activity C and activity D. Simple enough. And activity E can begin after I complete activity B. So from here, I'm going to have another arc going, and that's activity E. So hopefully that is clear enough. Now, F depends on C and E. Oh, hang on. If F depends on C and E, it's no big problem. I can just change this a little bit so that's D, that's C, that's E, and they coincide in the same node. Okay, so I've got 0, 1, 2, that should have been a 3, this is a 4, okay. D, E, F depends on C and E, so from C and E, I'm going to have activity F coming out, and activity G depends on D and F. So D and F should both lead into the same node, because G depends on D and F, they depend on the same node. So I'm going to have to tweak a little bit my diagram here, so let's change that around, which means that's going to have to change around. So this is going to be a 3, that's going to be a 4, activity D is going to go there, and then finally activity G comes out here and it leads into 5, which is the sync node, which is the last node. So that is it, basically. I know it looks a little bit fiddly that you start putting arrows and then you may have to change them around, but it's the right suggestion. Do it in pencil, do it in something you can erase, and start tracing the different activities and the different dependencies and numbering your nodes correctly. So hopefully, again, that is clear, but as usual, any questions, anything, please let me know. Let's go back to the presentation. Here you've got a couple of questions to try by yourselves. I will probably post the answers in a different document in Classroom, because I don't think my board is big enough to draw the activity network diagram for that precedence table there, but I'll put the answers later. But I suggest you try with yourselves and then check your answers and have a go. Right, last thing we need to talk about today. Last thing we need to talk about today is this thing called dummies or dummy activities. So just look at the precedence table in here. Okay, we've got 4 activities and their different dependencies. All right, so A and B do not depend on anything, which is why from node 0 I've got activities A and B. Now activity C depends on A and B, but activity D depends on A. And remember that C and D, the last 2 activities, have to meet at the final node, the sync node, which is number 3. So the problem we've got from what we have done so far is that we wouldn't be able to represent this precedence table because it just wouldn't work. You can try, but how do I show that C depends on A and B? How do I do that? Because I've got 2 arrows pointing in different directions, and I cannot have 2 arrows starting from the same node and finishing in the same node. That's not allowed. Okay, so I cannot have from 0 to 2 activity B, and I cannot have from 0 to 2 activity A. That just is not allowed. It's not how the diagram works. So what we do is create something called a dummy activity. It's a false activity. It's a fake activity that doesn't cost any time. It doesn't cost any money. It's just there to show that activity C, if you look at the diagram here on the right hand side, before I can start activity C, I must have completed B, but I must also have completed A, and I've got this dotted dashed line showing the dependency that before I can do C, I must have completed B, but also activity A via node 1. So that dashed line means that it's not a real activity, but it's there to show that C depends on both A and B. So like it says here in the presentation, it has no cost, it doesn't cost anything, it doesn't have an extra time. The only reason it's there is to show that C depends on A and B. Hopefully that's clear enough. So here's an activity. Here's a precedence table. You are going to try to draw an activity network using arcs like here, and it says here exactly 2 dummies. So maybe it's time to pause the video and have a go before I go back to the board and go through the answer. I'll see you in a bit. Bye. Okay people, back to the drawing board one more time. Here we go, activity network for this precedence table. So I start at node 0. From node 0, activity A, because it doesn't depend on anything, so that's the easy bit. And then B, C and D all depend on A. So from here, I am going to have B, C and D, which all depend on A. And I've got 2, 3 and 4. So I've done that, and that. Now activity E depends on B. So E depends on B, and that would be node 5, so done. F depends on B and C. So, well, I'm going to have to use a dummy here, aren't I? Because I need to show that F depends on C and B. So that's where my dummy comes into play, because remember, I cannot have 2 arrows pointing to the same node from the same node. So well, that's done. Then G depends on D and F. G depends on D and F. I could have I'm going to need a dummy variable here to show that G depends on D and F. So that's done. H depends on D. Fine. So that's H there. And I depends on G and H. If I depends on G and H, what I'm going to do is to actually have H pointing there, and then I takes me to node number 8. Now remember, what I said earlier is that you cannot have two arrows, two activities from the same node to the same node. That's not the situation here. I do have two activities from the same node, but they're not going to the same node. They are going to different nodes. And then I cannot have E hanging around there by itself. That's not allowed, because all activities must converge on the sync node. So actually, I'm going to have to tweak the diagram again, and from here, E is going to have to go all the way to the end. Hopefully you can see the diagram clear now. That's what I've got, that's my solution. Check with yours. I know it's a little bit fiddly, but we had the constraint, we could only use two dummy variables. That's the answer. Try again, rewind, have a check, and let me know how it goes. And one last thing, which I'm hoping that some of you were keen to spot, and I've done this to check that you were paying attention. Yes, what's the mistake that I've made? It's very easy mistake, very simple solution. But have you been paying attention? Were you thinking about it? Yes, my numbering is wrong. I've missed number 5. I've missed number 5. So 0, 1, 2, 3, 4. 5, 6, and 7. And that's it. That is the first bit of critical path analysis. Precedence tables and dummy variables, okay? So I think this is a good place to stop. This is a good place for you to start a bit of practice on your own. Have a go, give it a try. It's the first time you're doing this, so I don't expect greatness, neither should you. Have a good time. See you, bye.